Good afternoon, dear students. Today I'm going to explain one of the most important algorithm in artificial intelligence, that is A-star search algorithm. By the end of this lecture, you will understand what is search, why we use A-star search algorithm, how it works with real life and worked example, and what are the advantages and uses of A-star search algorithm. So before understanding A-star search algorithm, let us first understand the concept of search. Search simply means finding best path from start state to a goal state. Imagine you want to travel from your home to your college. That is unknown to you. You are going to your college for the very first time. There are many possible ways. There are many possible roads. You can choose anyone. So what you will do? You will choose the best and shortest path. That's exactly search algorithm works. Suppose you are going college from your home. Your home is the start state, the state where you began, and your college is your goal state, where you want to go, and the possible roads, possible moves are the actions. So that is the real life example of searching algorithm. There are two types of search algorithm. So let's first understand the types of search algorithm. There are two types. First one is uninformed. Uninformed is also known as blind. Uninformed is also known as blind. And the second one is informed. Informed is also known as heuristic. There are two types of search algorithm, uninformed and informed. Uninformed search algorithm is the type of search algorithm by which searching without any information, like no knowledge, no knowledge of goal. And the informed search is the type of search with information, mean use knowledge, use knowledge to find the steps to solution. Example of uninformed searching is DFS, depth first search, works on stack, stack, last in first out. That means there is no guarantee of shortest path. The example of informed search is BFS, best first search, works on queue. FIFO, first in first out. That means there is guarantee of shortest path but ignores the direction towards goal. And the uninformed search doesn't guarantee the best path. Search width before wide. So there is no guarantee of shortest path, but in BFS there is guarantee of shortest path, but it also ignores the direction. Let's move to our topic, searching algorithm. What are the problems in BFS and DFS? Why we use A-star search algorithm? As we already understand that BFS, best first search, explore all nodes at each level. Like it works on queue. It works on queue. It guarantees shortest path but ignores direction towards goal. It's very slow for large graphs. DFS doesn't guarantee shortest path. It is not optimal. It explores deep before wide. So it can get lost in finite branches, not reliable for path finding. So that's why we use A-star search algorithm. A-star search algorithm combines the actual cost traveled. We denote it as GN, and the estimate cost remaining. That means remaining distance. We denote it as HN, and is equals to the final total cost. We denote as FN. So we use A-star search algorithm because it gives the best and shortest path, and it also use both the distance that we already traveled and the remaining distance. Let's understand it clearly. The core formula, the mathematical equation is Fn, that is equals to Gn plus Hn. Gn means past distance that is already traveled, and Hn, future distance mean remaining distance, future distance. Let's understand. GN mean actual distance. Actual distance, distance that we already traveled from any node. HN, heuristic cost. Heuristic cost mean remaining distance from any node. And FN mean total estimation, total cost combination of GN and HN. A star search algorithm always expands the node with lowest FN, not lowest GN or FN, but lowest FN. It calculates both GN, both remaining and future distance, and find the best and short path. Let's understand with an example. Here is a graph. It is a start state and it's a goal state. Start state mean where we began, and the goal state mean where we want to go. GN always remains 0. GN always remains 0 for start state, and HN always remains 0 for goal state, because GN means pass distance. So there is no pass distance from the start point, because the distance start from it, and HN means future distance. So there is no future distance, because goal itself is the last distance. So GN, the distance from node to start, known as GN, past distance, distance that is already covered, and the distance from node to goal is denoted as GN, mean future distance, distance that to be traveled. So let's understand. GN 0 for start state, and HN 0 for goal state. Because there is no past distance in start state, and there is no future distance in goal state. So what is 6? 6 is the assumption to estimate distance. We assume that the estimated distance will be 6. So there is the best short path is 437. 437. If we check the node B, there is 4 plus 4, 8. This is not the shortest path. So the best path, the shortest path will be 7. Let's understand what is the best path, how A star search algorithm used to travel. If it start from node B, if it start from node B, so GN is 4, HN is 4. GN is 4, HN is 4. 4 plus 4 is equals to 8. And if it start from A node, GN for A node is equals to 3, and HN for A node is equals to 4. 4 plus 3 equals to 7. So this is the best shortest path that AI search algorithm used to go. That's how A star search algorithm works. Let's move and understand the algorithm step for A star search algorithm. Firstly, add the start node to open list with F start is equals to 0 plus H start. Open list mean the distance need to cover. F start is always equals to 0, that we already understand, plus H start. H start mean the future distance. So select the node with lowest Fn. Select the node with lowest Fn. Fn mean past distance, GN, plus future distance, HN. Select the node with lowest FN. Then move the node to closed list. Closed list mean distance already covered. Then expand. Calculate FN for all its neighbors. If goal is found, trace back the path, else repeat from step second. Repeat from step second. What are the advantages of A star search algorithm? Why we use A star search algorithm? First, it's complete. It's complete mean it if there is a solution, it always find the best and the shortest solution. It is optimal. Optimal mean it guarantees the shortest and cheapest path. It is efficient. Efficient mean only expand nodes that seems promising, that have the short and best path. It's flexible. Flexible mean heuristic can be turned for any domain. Real world application of A star search algorithm is Google Map, finding shortest route calculation, GPS navigation, robotics, video games, autonomous cars, etc. Let's recap what we learned in this lecture. We learned firstly we learned a search algorithm. Search is about finding optimal path from start to goal. BFS and DFS have limitation. A star search algorithm overcomes. We learned the simple mathematical equation to find the best path in A star search algorithm. Fn equals to Gn plus Hn. A star search algorithm always expand the node with lowest Fn. Fn is equals to Gn plus Hn, past distance plus future distance. It is complete, optimal, and efficient applications like Google Map, GPS, robotics, games, autonomous vehicles, etc. I hope you will enjoy and understand it. Thank you.